Streaming right now. Okay, what am I doing? That's not it. There we go. So, okay, let's see. We're trying to solve a problem. So I'm just testing. Give me 1 minute, folks, and then we could be going. All right, so I think I am actually on live. I'm going to go to send you guys the right URL. Seems like I just was not able to stream on a different URL right there. So here we go. I'm online now. All right, let's see if we're on streaming. I am streaming. Is there anyone here? Anyone here? Watching right now is me, one person. And Okay. Great. We have some people watching. And all right, great. I just need to set up some things. So I'm on now, and I think we're good to go. So questions. I'm looking for some questions. Here we are. And let me just double check. The assignment is here, in case anybody has any questions on the assignment. And we have, so I'm looking to see if there are any questions. So, I have a question from Hannah. How do we do hypothesis testing when for a survey with two possible answers? I'm not sure when you say a survey with two possible answers what you mean. Are we talking about a problem involving two populations? Because we do have a situation where we might be interested in testing the difference between two population parameters. Could be two population means, two population proportions, but we have not covered two population proportions yet. We have covered two population means. So when we're looking at the question of testing for a survey with two possible answers, and I'm not exactly sure what you're asking me. If you're talking about whether or not we testing so let me just adjust my screen here. Give me 1 second. So bear with me for a minute. I'm just adjusting something here. So it gets cut off. All right. I just noticed that the things are getting cut off. Okay, so I have a number of questions coming at me. Let me try to answer them. So Hannah asked the first question about how do we test hypothesis where we have two surveys. So let me just see what question 3 is about. Okay. Question 3. Question 2. I see question 4, then question 3. Where's question 3? Okay, so we have question 3. A Wall Street Journal poll asked respondents if they trusted energy efficiency ratings on cars and appliances. So 552 people responded yes, while 531 responded no. Okay? So you have two answers, but two groups of answers, but really that is just a single sample. It's kind of like me asking 50 people if they like Pepsi or Coke, and I said 30 said yes, they like Coke, and 20 said yes, they like Pepsi. So basically the two of them add up to the entire sample. And that's what you have in this situation. So these are not two separate surveys. It's a single survey, and the individuals who responded had two choices. Either they would say yes or they would say no. So in that case, if I were to ask you for 50 people, if I were to tell you 50 people said that they like Coke, out of 50 people, 30 people said they like Coke, and 20 said they like Pepsi. Well, you could use that information to state what proportion actually like Coke, which is 30 over 50, 60%, or what proportion likes Pepsi, which is 20 over 50, which is 40%. So even though you have those two sets of numbers, they're really just part of one sample. And that way, depending on what the question is asking you, you can simply you could simply determine the appropriate sample proportion for you to use. Okay, so that's what you would do in this case. Kyle, how do we determine what the null hypothesis is and the alternative? So Kyle, there's no magic formula to this. The more questions you do, the more you review the notes in either in MindTap or the textbook, the more you will become accustomed to identifying the null hypothesis. There's really no magic formula. But let me try to see if I can give you a guide. The important thing to note is that the alternate hypothesis is the research hypothesis, meaning that it is the question that you are interested in answering. So often you will see in the question, is there enough evidence, or is there evidence that the mean is greater than some value? That is the research question. So then you will try to prove from your sample that you have enough evidence that the mean is greater than something. The null hypothesis is just opposite to that. Okay? So it's just opposite because the whole design of a hypothesis test is what we call proof by contradiction. So we're trying to contradict the null hypothesis to support the alternative. So the alternative hypothesis is the one that you want to prove or that you want to find evidence to support. Okay, so we call it the research hypothesis or the alternative hypothesis, and it's usually written in the question. The way the question is usually framed, it might say something like, based on the sample data at a level of significance of alpha, 5% or 10%, is there sufficient evidence that the manufacturer's claim is true? So that is your alternate hypothesis right there. Okay? Always remember this though, that the null hypothesis is always the one that contains the equal sign, never the alternate hypothesis. Why? Because we have to set the population parameter to a value equal to something, and that you always set that parameter in the null hypothesis. In other words, the null hypothesis is where you say, well, let us assume that the person is innocent, right? So we're saying that, the state of the defendant is innocent. We are saying that defendant's state is equal to innocent. But now we're going to try to find evidence to prove that they're guilty, okay? So always remember the equal sign goes in the null hypothesis, never the alternate hypothesis or research hypothesis. So I hope that helps. Kyle, I'm not going to tell you that's a two-tailed test. You need to figure that out. I think I've explained many times that a one-tailed test indicates a direction. Two-tailed test, there's no particular direction that's indicated. So you have to do you're asking me to answer the question for you. And I specifically said, do not ask me to answer a specific question, but to ask more questions about the general ideas and the concepts. So I will just say this to you. I won't tell you if it is a two-tail or not, but I will say in one-tailed tests, there's a direction. So for example, I could ask you, is there evidence that the mean has increased? Increase is a direction. It goes up. Is there evidence that the mean has decreased? Down. Is there evidence that the proportion of employees who take sick days has dropped? Dropped is a direction. Now, if I ask you, is there evidence that there's been a change in the percentage of employees who take sick days? That doesn't tell you what direction. It simply says, has there been a change? The change could be positive or negative. So that's where you have two possibilities, hence a two-tailed test, right? In the case of when you have direction, then it's a one-tailed test. Increase, that's just one direction. Decrease, that's another direction. So I think you have enough information there to figure that out. Next question. How should we approach question 2B? I think I just said that I do not ask me to work the assignment for you guys. Come on. So Michael, I'm not sure. You need to ask me a question about to explain something, a concept, to clarify something if there's some issue with the assignment, but not how should we approach 2B. I may as well sit with you and show you how to do the assignment. So it's not, that's not what I want to do right now. I want to clarify issues for you guys, not to tell you how to work the assignment. So please ask me a different kind of question. So Hannah, you said I was wondering the same thing just because of the differing by 50%. It didn't say, if you read the question, it didn't say differing by 50%. It says differs from 50%. That's two different things. Differing by 50% is like saying 100 and 150. 10 and 60. That's different by 50%. But the question is asking you, is there evidence that the proportion differs from 50? So what is differing from 50? Think about that. So differing from 50, what's a number that's different from 50? 49s, 52, 61, 38. All these numbers are different from 50. Okay? So I think you should be able to answer that now. Marshall, I'm reading your question. What's 1A? Let me see. What's 1A. One A is asking you for a probability. Assume the true mean volume. What does that mean? Is that sample or is that population? A true mean volume of soft drink in a 2-liter bottle is 2 liters. What is the probability that a randomly chosen bottle will have a volume of 1.99 liters or less? That's chapter 6, folks. Okay? So the way in which this assignment is designed, we build a number of questions are asked to kind of reconnect you with material we've done before so that you don't see what we're doing as a set of discrete topics. They are all connected. So by asking a question from chapter 6, and then there's a question from chapter 7, which then brings you to chapter 8. And as I mentioned over and over again, the material builds on each other. And so that's why it's so crucial to stay on top of it. It's one of the reasons why I chose MindTap, because MindTap gives you an opportunity to practice, to engage with the material, and that makes it a whole lot easier when it comes to assignments. All right, because typically in a classroom, we only get to do 1, maybe 2 examples. And if you are of the mindset that your assignment problem should look just like your example, no, it does not work that way. That might be okay for 1205 and 1206, but we don't do that in 1207 simply because a lot of the problems have different contexts. We could apply statistics in so many situations. And so the wording that we come up with will depend on the context. So if I'm framing a question around a confidence interval and I'm doing it in a business setting, it will read one way. I could ask you a very similar question, but put it in a medical setting. If I put it in a medical setting, all of a sudden you're lost because the medicine doesn't sound like business. Or if I put it in a sports setting, then you say, well, the sports does not sound like the medical setting. So we can't give you all scenarios. What we've given you are the models that are important. And so, it's very important to really try to understand the concepts that we're applying. So we're using stuff from chapter 6, chapter 7, chapter 8, chapter 9, and I believe the first part of chapter 10. Okay? Okay, so I see here, so is it still stuck? Let me know. Hopefully not. Okay, so let's see here. We have, I think it's okay now. All right, I'm just working through the questions. Diane, when do we use the formula degrees of freedom is calculated n1 plus n2 minus 2? When do we use that formula? Okay, so the formula that would allow you to use that degrees of freedom is when you are testing hypothesis for 2. 2 in, let me see here, let's go here. So when you're testing the difference between two means, all right, mu1 minus mu2, and sigma 1 and sigma 2 are unknown. So if sigma 1 and sigma 2 are unknown, then in that case we use a t-distribution. T-distribution is t is equal to, so that's what our test statistic would look like, or the formula that we would use for confidence intervals, etc. So it's t x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by sp squared over n1 sp squared over n2. Now, we have not touched that model yet. That model, I'm going to touch on it tomorrow. There are two models that I need to touch on, which is this one, and one that deals with testing of difference between means when we have what we call matched pairs. But that's not actually in the assignment. So you don't have to worry too much about that, all right? It's actually not in the assignment. Let's see here. So that is the formula for T. But then what happened is that the degrees of freedom for this, the degrees of freedom is n1 plus n2 minus 2. All right? The other thing that you need is a formula for the pooled sample variance, which is given by n1 minus 1 times S. Let me just make up some space there. I need some space for this one. Okay. n1 minus 1 times s1 squared plus n2 minus 1 s2 squared over n1 plus n2 minus 2. So that's to calculate the value of SP that we're going to use in this formula. I will explain that tomorrow, but I'm pretty sure if I go back to the assignment, I don't think that that is actually part of the assignment. So I will double check that. Let's just double check. So the question, I know that you think, requires that. It does not, because this will be on our next assignment, not the current assignment. Okay? And I will explain that in our next class. Okay. So that's for Diane. Jessica, you did a similar question in class yesterday as to number 4. That's correct. So you should be able to handle that question. Jessica, thank you. There is a part in the equation where we need to find mu1 minus mu2. Yes. On the question you did in class, you came up with 0. You don't understand how to find this on this question. Okay, again, remember, we're getting specific now. But let me just put it this way to you, all right? And let me just issue a bit of advice. If you start the assignment without reviewing your materials, and I'm not saying that that is the case here, but I know in the past a number of students have come and they just want to jump into the assignment without reviewing notes and really trying to understand the appropriate sections that the assignment is based on. If you do that, chances are you'll get stuck. All right, so it's always useful to review the material completely, look at a couple of examples that have worked for you, either by myself or in MindTap, and then start the assignment. You might find it actually a lot easier. So if we look at the formula, when we're talking about two populations, we had z is equal to x bar 1 minus x bar 2 minus mu1 minus mu2 over sigma 1 squared over n1, sigma 2 squared over n2. Oops, I see that my thing is disappearing here. There we go. All right, so given that we have, this is our formula, you want the value of mu1 minus mu2. Well, mu1 minus mu2 comes from the null hypothesis. So when you state your null hypothesis, HA, you will have the null and alternate hypothesis stated in words first, and then you'll convert it to symbols. So if you have something like this, mu1 minus mu2 is equal to 0 versus mu1 minus mu2 is not equal to 0. Remember, this gets its value from HO. Look at the value. The value is 0. So that's where that comes from. So what we assume is that there is no difference between mu1 and mu2. And then the research hypothesis is asking us to test whether or not there is a difference between mu1 and mu2. Okay? So that's what's happening in that situation. All right. Let's take some other questions and see what we're looking at here. Corey. Am I able to email out a sheet with formula and the names of the formulas? Okay, so I certainly will do that, but I also want to mention that the formulas and their names are also in our ebook in MindTap as well, in case you're looking for it. It's actually right there. As we go through the course, I explain the formula, but what I do on the board is not independent or does not preclude the use of the ebook in MindTap. So a lot of some of what you guys are asking me are actually in MindTap, but I know that we would like to do the entire course just based on what I do in the class, but it's not enough to simply depend on what I do in the class. Reading the ebook could be very helpful. So I will see what I can do with regards to that. I do have a formula sheet that is labeled, but remember, in the final exam you will not have a formula sheet that is labeled. So the more that you get used to the sheet without labels, the better you'll be able to use it in a final exam. Okay, so Hannah, you asked a question. I think, folks, what's happening is that my CPU is being challenged by what I'm doing. All right, so let's just see here. Jessica, the critical value approach, if you look at the one I did in class, I don't think you need another one. You need to tell me what you don't understand so that way I could explain that better. But the one I did in class should absolutely help you answer that question. And so if there's a part you don't understand, let me know so that I could explain that better. But let me just mention this. The critical value approach compares the Z critical or T critical with the value of the test statistic. The p-value approach takes that Z value or T value, converts it to a probability, and compares it to the significance level. So if we understand that, what happens is as you do the calculations, because first of all, you have to state all your steps. Step 1, which is the hypothesis. Step 2, the decision rule. Step 3, the step 3 is the decision rule. Step 2 is the test statistic. And then once you do the calculation in step 4, you will get the value of the test statistic. So the classical approach requires you to compare that value of the test statistic to the critical value that you used in the decision rule. And then once you apply it, that's the classical approach. To get to the p-value approach, you will now take the value of your test statistic and you will convert it to a probability. And so if it's a Z, you use the Z table. If it's T, use the T table. And then you compare that probability to the value of the significance level, alpha. And that does it for you, okay? All right, so we have in your hypothesis, that's from Ben. In your hypothesis, can you have mu1 greater than mu2 and mu1 less? Oh, absolutely. Absolutely. Because what is that? One of them will have to be the null, one will have to be the alternate hypothesis. So this is not a calculation, this is a statement. In your hypotheses, you are basically going to make statements about the population parameter. So you could say HO, HA, mu1. Let me see how you have them. You have it mu1 greater than mu2, mu1 less than or equal to mu2. So mu1 less than or equal to mu2 versus mu1 greater than mu2. Now to express it as a difference, I would put, this is the same as mu1 minus mu2 is greater than 0. And you can see why that is. If mu1 is greater than mu2, that's like 5 being greater than 2. Then if I take away mu2 from mu1, the difference should be positive because mu1 is larger than mu2. And then up here, the reverse should be true. Mu1 minus mu2 should be less than or equal to 0. All right? So that is what we have here. I'm going to just go back to the big picture here. Cool. So Hannah, let me see. Before I come back to you, let me just make sure I'm getting the other questions and I'm not skipping over anybody. So that was Ben. So Hannah, yes, you ask, is mu1 minus mu2 equal to 0 even when hypotheses are inequalities. So that's a good question. Let me explain why. All right. So you're looking at, for example, this case that I have here. You're looking at this case. So the question is, what value do I put in my formula when I go to calculate z or t? X bar 1 minus x bar 2 minus mu 1 minus mu 2. So what value do I put? You see, what happened is that we have to assume a value for, mu 1 minus mu 2. So what value do we assume? Well, in the null hypothesis, we're saying that we believe that the difference between those two means is less than or equal to 0, right? Less than or equal to 0. So let's put it, let me just try to draw a picture of that for you. So essentially, let's call that the 0 mark right here. On this side, or to the right, this is where the mean, mu 1 minus mu 2, greater than 0. That's what we want. That's what we're looking for. We want to test that, right? But then to the left of that is mu 1 minus mu 2 is less than or equal to 0. So we want to find evidence to support, this is our HA. This is our HO. We want evidence to support HA. All right? So if we want evidence to support HA, we have to assume HO is some value to conduct our test, because we're going to need that to calculate the strength of our evidence. All right? So what should we set the value to be? The reality is that if we have proof that mu 1 minus mu 2 is greater than 0, then we clearly have proof that it is greater than any of these values that could be down here, any of these values. So why don't we just set mu 1 minus mu 2 to 0? Why don't we just set it to that value? And if we find evidence that it is greater than 0, then that makes sense. It would be greater than that 0 that we set it to, or any other value that we could have picked that was less than 0. So this is called a boundary test. In other words, we set a value at the boundary, and then we do the test at the boundary. It's called a boundary test. Handwriting look pretty bad here. That's not coming up. It's stuck now. So boundary test. B-O-U-N-D-A-R-Y. Okay. So as I was saying, this is called a boundary test. So we set the value of the difference to 0, because we simply say it's less than or equal to 0. So we're just kind of just working with the equal part. Let it be equal to 0. And then let's see if we have evidence that is bigger than 0. If we do, great. If we don't, we're not trying to prove that it's 0. We're not trying to prove that it's less than 0. We just are not able to reject the null hypothesis. We're not able to say, guess what, folks? We have evidence that it is less than 0. No, that's not what our objective is. We want to simply find evidence that it is greater than 0. And so we'll say, let's consider it to be 0 and see if we have evidence to support our claim. All right? Good. Let's continue. Jessica Smith. I don't understand what they're asking. I'm not sure what you're referring to, Jessica. So you will need to be a little clearer here. Okay, so Chris Bluto. For a two-tailed test, once you get the p-value, do you divide it by 2? Well, what happened is that you would, I suspect what you're asking me is when you get the probability from the table, do you multiply it by 2? So let me illustrate this for you. Let's bear with me a moment, folks. I need to just make a change to my I need to do something here. Let's see if I could do that. I need to be able to have things fit right here. Give me 1 second. I need to make sure that when I write on the iPad that I'm seeing everything. Okay, so part of it is hidden, and I'm just trying to check my settings to make sure that I could see everything. Bear with me. It's just the resolution, not the resolution, just what it says. All right, so let's see how that works out. Okay. This part of it does not being seen. Okay, part of it is being hidden. I'm not sure why. Anyway, we'll make it work. So let me get back to the questions. So for two-tailed tests, do we divide by 2? So let me just kind of show you what we're talking about here. All right. Say I've done a calculation and I found my test statistic. So this is 0, and I found my test statistic somewhere over here, and this is my Z observed. So this Z would have been calculated. I'm assuming that the sampling distribution is a normal distribution. So what happens now is that if the test was a two-tailed test, so let's just say we have this situation, HO mu1 minus mu2 equal to 0 versus HA mu1 minus mu2 is not equal to 0. Now I notice that you're not seeing what I have here, but I think you can see it now. There you go. All right, so what happens now is that if we find our test statistic and we put it on the map there, so this would be this area. We would calculate that area to the right of the Z value. It turns out that that area, P, Z greater than or equal to Z observed, Z0, whatever that turns out to be, is really equivalent to half of the p-value in a two-tailed test. Because what happened is equivalent to the Z0 is a negative Z0. And that negative Z0 is equivalent in terms of the evidence against the null hypothesis, right? It's equivalent in terms of the strength of the evidence. So what happened is that this piece right here is half of the p-value. This piece on the other side is the other half. But we don't have to calculate the two of them separately because the standard normal is symmetrical. Because the standard normal is symmetrical, then all we need to do is calculate one of them and multiply by 2. So then the p-value would be equal to twice the probability of Z greater than or equal to Z0. So once you find that probability, you just multiply by 2, and that will give you the p-value. Okay? So Chris, I hope I answered your question with that. Thank you, Morgan. I think you got it right. Hannah, To clarify my previous question, when you do a comparison, okay, so yeah, I think I've already answered that question. That essentially the value comes from the null hypothesis, and that if the null hypothesis, what you will end up having is something like the mean is equal to 0, the difference between the means is equal to 0, or less than or equal to 0, or greater than or equal to 0. One of those three. The equal sign is in that null hypothesis. You simply set the difference to the boundary, equal to something, either equal to, well, I mean equal to 0 in this case. So it becomes a boundary test. And so if you find evidence that it is greater than 0, it's immaterial whether or not the difference, whether or not you wanted to claim in HO that the difference was -1 or -2 or -3. If the evidence shows that it's greater than 0, all of that doesn't matter. All right? So the important thing is you have to set the difference equal to something, and you set it equal to that value, which is 0, which is what we are proposing in the null hypothesis. Let's keep on going. We have more comments or questions. So, when using the t, how do we calculate the p-value to use in the equation? All right, so finding probability with the t. I know I did an example, but I will do one again. I will demonstrate it, for you. When using t, how do we calculate the p-value to use in the equation? P-value less than or equal to alpha. Okay. So basically the question there is how do I use the p-value, the t distribution? If you know how to use the t distribution, then we'll do that. So let me just try to explain that aspect. All right. So it's important to understand the nature of the t distribution. So say we calculated a value. I'm just going to just use, say, our t value was 2.16, and our degrees of freedom was 16. Then what is the area in the tail? So essentially, what we're looking for is this t is equal to 2.16, and the degrees of freedom, we already said, is 16. So we want this area in the tail, which would be our p-value if it is a one-tail test. If it is a two-tail test, it would be twice that amount. Okay? So how do we find this probability? So what you do is you look at the t-table. Look for 16 degrees of freedom, because that's what's in this column right here. Go along the line of the 16 degrees of freedom and try to find the closest value, get to 2.16. Chances are you're not going to find it exactly in the table. So when you find the closest number to 2.16, depending on where it is on that line, you go straight up to the areas in the tails. More than likely, a value like 2.16 may very well be bracketed by two values, one on that side that is slightly smaller, one on that side that is slightly larger. So for the slightly larger one, we go here, we will get one area in the tail, let's call it A2. For the smaller one, we get an area in the tail, A1. And so therefore, for 2.16, that area, let's call it A, must be between those two values right here. So it would be greater than A2, but less than A1. So you could actually write your probability as an inequality, and more than likely that's what we'll end up having to do, is that we have to write the probability as an inequality. So your p-value will end up being, in this case, less than A1, less than A1, but greater than A2. but less than A1. All right. To see this, I need to bring up a t-distribution. So let me try to bring up a t-distribution, and then I could demonstrate that to you. Let's see here. What am I looking for? If I add file, folder file, let's add a file. So we go to a Google Drive, and we will get the tables. Where are the tables? Statistics. There we go. And we want the tables in here. So let's get a T table. Perfect. So we have a T table, and I'm looking at 16 degrees of freedom, which is right here. Oh, I got to choose it first. Give me 1 second. Loading. Meantime, let me see what else I have. Questions. Okay, so here we go. So the example we had was 2.16, a t-value of 2.16, and the degrees of freedom of 16. So if you look up, if you look at this diagram, 16 degrees of freedom is down here. Okay, so we can't see it, I gotta move it. There you go, 16 degrees of freedom. So we're going to be looking for 2.16. Where's 2.16? Well, 2.16 is between those two values right here. All right? If we keep going to the right, we get to 2.53. That's not what we're looking for. So if I now go up here, so what am I being told? What I'm being told is this. The area in the tail, or the area corresponding to 2.16, will be smaller than 0.025, but will be larger than 0.01, right? Because that 2.16 is in between those two values, right there. It's in between those two values. And so that's how you get the area from a t-distribution. You have to have the degrees of freedom in the first column, the value of the t, go along the line, and then we'll go up to the area in the tail and look at where it falls. And then you would have to more than likely express it as a, more than likely you'd have to express it as an inequality, all right? Okay, you're welcome, Chris. Any other questions from the folks who are listening? No questions? Just a little reminder, in case you're looking for, I just sort of kind of illustrated how we'll find the area or the probabilities in a t-distribution. In MindTap, there is an example as well too. If we go to the appropriate section of the, so I think we did the t-distribution in chapter 8 when we did sampling distributions. So if you go to MindTap under section 8 or chapter 8, there's a section that introduces the t-distribution. There will be a short video that tells you how to calculate probability using the t-distribution, right? So if you want to check that out as well, that could be helpful. I'm looking for some more questions. No more questions? Let's see. What else can I explain to you? So let me just kind of review again the hypotheses, because people seem to be having some difficulty with the hypotheses, just in terms of HO, HA, that sort of stuff. All right, let me do that. Just going to switch screen to full screen here. Okay, so here we go. So in terms of our hypotheses and the one-tailed test versus a two-tailed test, if your hypothesis is stated like this, HO, HA, so that's a single sample problem we're looking at. The mean is greater than or equal to something versus the mean is less than, let's call it mu0, just some value of mu0. If that's the case, then that's a left-tailed test. One of the ways to get a hint is look at the direction of the inequality. This inequality right here is pointing to the left. So that should be a hint for you. All right? Because what we're looking for is evidence that the mean is less than a particular value, and that if we're looking for that kind of evidence, then that should take us into the left tail of the distribution. And so it's a left tail test. All right? And that's where you have your Z critical, your T critical. If we're looking at this case, HO, HA, mu is less than or equal to 0, not 0, sorry, less than or equal to mu0. Versus mu is greater than mu0. So look at the direction of the arrow, it's pointing to the right. So therefore it's a right tail test. So our evidence that we're searching for should occur in the right tail, because we're looking for values that are greater. If we're looking for values that are greater than mu0, it will take us in this direction. Values less than, it will take us in that direction. All right? So in that case, we have a right tail test. When is it not equal to? If you're told, if you see this, HO, HA, mu is equal to mu0 versus mu is not equal to mu0. So if it's not equal to, and I drew the distribution for you, if it's not equal to 0, then the values that basically satisfy this are values that are bigger than mu0 or values that are smaller than mu0. So I just want evidence that it's not equal to mu0. So if mu0 is 15, for example, I want values like 20, 30, 40, 50. That's different from 15. Or values like 0, 1, 2, 3, 4, 5. So in which case, I have a two-tailed test. And the size of each tail is alpha over 2. Alpha over 2. whereas the size for the tails in the case of a one-tailed test is just alpha, alpha. Okay? Alpha. There we go. Okay. All right, so that gives you the three different scenarios that we consider whenever we're doing this. Yes, Morgan, it will stay on YouTube. It will be processed and you have access to it. No problem. But it will be a different, this URL here is really for live streaming. And when it gets processed, it has a different YouTube URL, but then I will post that in the Facebook group for you guys to actually check it out. Okay, not a problem. Anybody else? We're now 10:36, and I wanted to give an hour. If there are no more questions, then you guys could ask me some more questions that are not. Can you work question 3 for me? Can you work question 4 for me? But ask me to explain the general concepts for you. But then after that, it is for you to apply the ideas, all right? Good. So hopefully tonight's session actually helped you with a couple of things. Okay, any questions? Going once, going twice. So I'll stay for about another 5 minutes in case anybody have a question. Let me see what else I should mention to you. That's useful. And then if you notice, all the steps are the same. All the steps are the same. Here, let me just quickly run through the test statistics that we've covered so far. But it's your job to know which ones to use, all right? And folks, don't try to know it don't try to take shortcuts without going over your notes, without reading the sections, the appropriate sections of the textbook, and you have the e-textbook, so please use it. So we did this test statistic right here. Z is equal to x bar minus mu sigma over root n. So clearly this is the test statistic when we're doing a test, a hypothesis test for the mean. And with the hypothesis test for the mean and the population standard deviation is known. Notice that I have sigma, so it's known. Second one is x bar minus mu, sorry, not sigma, but s over root n. S divided by the square root of n. Now notice something here. S means that sigma is unknown. So if sigma is unknown, why am I not using t? Well, the reality is that we always use t when sigma is unknown. However, if your sample size is greater than or equal to 30, then you could apply the central limit theorem and use z is equal to x bar minus mu s over root n. So keep that in mind. If your sample size is large enough, greater than or equal to 30, and sigma is unknown, you certainly can use this formula. However, technically speaking, the correct formula to use is t is equal to x bar minus mu s over the square root of n with degrees of freedom of n minus 1. Okay? That's what you need to be using. In the case of a one-tailed test, p-value is either equal to p z greater than z0 or p z less than or equal to z0. So basically that's one-tailed test, right? That's if we're using z. What if we're using t? Then it would be or pt greater than or equal to t0 or pt less than or equal to t0. Okay, less than or equal to t0. Okay, so that is the case of a one-tailed test. And the one that you use will depend on the direction. If it is a left-tailed test, you'll end up using this value or this value. If it is a right-tailed test, you'll end up using this value or this value. All right? Because if it's a right, notice the great, it will be z greater than or equal to z0. If it is a left-tailed test, z less than or equal to z0. And the same thing for t. When it is a two-tailed test, however, for two-tailed tests, in that case your p-value, the p-value would be equal to twice the probability of z less than or equal to z0 or twice the probability of z greater than or equal to z0. Now there's another way to write this. Sometimes people get confused. It's just to say this, that it is twice the probability of z greater than or equal to the absolute value of z0. What it means is that I don't care if z is negative or positive. If I take the absolute value, then that's all that really matters. In other words, if I look at this here, if I happen to get a positive z0 or a negative z0, for a two-tailed test, it really doesn't matter. I could take twice this area or twice this area. But the reality is that to get this, all I need is really just the magnitude of the z0, or to get this value is the same as what we have over on the right side. So I just need the magnitude of the z value. All right. So this is kind of like a neat little way to state it without worrying about the signs. But some people have some challenges with rationalizing the absolute value. So I guess I've shown it. So I show it to you in using two steps, which is if the z is negative, then it's twice the probability of z less than that z negative. Or if it is positive, then it is twice the probability of z being greater than or equal to that value. All right? That's basically it. So that's a p-value right there. One population, one tail test versus two tail tests. So hopefully that is helpful. All right, folks. So on that note, you probably noticed my voice is starting to wane a little bit, which means that it's time for bed. And if you have more questions later, we'll chat in class tomorrow. So, see you then. Have a good night. And this will take a little while to process. I will send you the link in case anybody wants to come back and watch it again before the assignment is passed in. Okay? Take care. Have a wonderful night. And thank you for joining in. I hope I know there was one time where it froze, but that's because to do web streaming, I guess you need a powerful computer. My computer is okay, but probably could be a little more powerful to allow me to stream in 1080p. I'm streaming only in 480p, but that's good for the web. Good enough, I should say, for the web. All right? So, au revoir, à la prochaine. We will see tomorrow. God willing. Good night.